Welcome to the detailed discussion on the winter of 2016. So the big $1 million question is how will it compare to last year? And I can tell you guys it's not going to be as cold as last year. Slightly cooler than normal in the temperatures I have here, which means say maybe 1 to maybe 3 degrees below normal. Cold down here because again I think we're going to have a lot of storminess down here in the south with an active southern jet. So cold down here, average through here, and warm in the west. I really do believe there is going to be ridging in the west again this year. So let's jump right into it. Snowfall kind of follows that same path. I'm expecting 1 to 2 big storms this year just because of the jet stream configuration I think we're going to have. So 30% of normal, 15% above normal here. Mixing issues on the coast because we're going to have a warm Atlantic. So I think a lot of these storm tracks, we could see a couple more interior events that would jeopardize actually a lot of the mid-Atlantic here for getting all snow from the storms. But overall, mountains will do well, I think, and up here because of the ridging, I'm expecting below average snowfall. So the big thing we're looking at, right, sea surface temperatures. It's no secret we have a very big El Nino right now. Okay, it could be historical. Looks like it's going to peak over the next month or two. And El Ninos really strengthen the jet stream. They strengthen that trough off the west coast, the Aleutian low. And if that low gets too close to the west coast, you get the whole country flooding with Pacific air. But this year, we have a very interesting situation. We have all this warm water off the Baja. We have all this warm water off the coast of California and this little cold pool here. So we're in basically a positive PDO with this pattern, which does promote ridging and troughing in the east, not to mention the Atlantic configuration. If it gets its act together up here with some warm water, we could see some blocking. But all El Ninos are definitely not the same. I know other folks have said that, but I agree with it because it makes sense. For instance, 1998, right? Warm water, very east weighted, not a lot of warm water off the west coast. Here's the cold pool out there. So pretty much it's not as extensive. So this trough was naturally able to develop closer to the coast, as you could see right here, and it flooded the whole country with warm air. 1983, El Nino was a little more broad, but we still had that little bit of an east weighting here. No warm water off the coast. So again, this is what we look like now. This is 1983. So both two very strong historic El Ninos, which this one occurring now is rivaling. But again, the rest of the Pacific looks a lot different. If we go into the winter, what the models are projecting, you could see this is the configuration expected to stay. Okay, so again, think about it. You have cold water, warm water, a lot of convection down here. Warm and cold develops a baroclinic boundary, which you could have a trough that is just to the east of where it was last year. Okay, so what I did was I said, let me find some analogs that look similar to this configuration. And this is what I came up with. Okay, 2015 times 2 because of the warm Pacific, 98, 83, and 58 looks like this. So keep a close eye on this. And this is the projections. Okay, so again, it's pretty similar to what the models are projecting. And if we go to what the actual weather pattern looks like using my analogs, you could see. No, that's not it. I hope not. That doesn't end up happening. But you can see there's that big El Nino trough, but it's a little bit more off the west coast. You have a mean ridge position over Montana, and you have all that undercutting underneath. This is a very active pattern. So I demonstrated that with my jet stream diagram here. And interestingly enough, some of these models like UK Met are showing that mean ridge just over to, say, central to western Canada, which promotes the storminess underneath, which again is what my analogs are showing. So the models are lining up to my analogs, which are based on the sea surface temperature configuration and a very strong El Nino. Okay, so that's very interesting. Now, also we have to look at the snow cover, right? In addition to the oceans, because what happens is when you get above normal snow growth over Eurasia in the fall. And more importantly, it has to advance quickly. It can't be like last year where you get all this above average snow cover, then at the end of the month it kind of fizzles out. You want to see snow growth building. So this is what we look like now. This is above normal. You can see next 10 days, the models are projecting, there could be quite a bit more snow. And what that does is it strengthens the Siberian high, which causes, say, a poleward heat flux of energy, which breaks up the polar vortex and could cause a negative Arctic oscillation in the winter, which means cold and storminess. Okay, so snow cover right now is on our side. I showed you the UK Met model. The NMME model, which blends a lot of different models, finally starts catching on to this idea of cold underneath. Again, it's hinting that it could have a ridge position over here along the west. So again, that's starting to look like my analogs. Okay, looking at the sun real quick. We're not at a sun maximum. We had this dual maximum last year. Now we're declining, so that means ozone could build up, which promotes stratospheric warming. Again, the sun is not going to throw a wrench in the equation. So what we're going to end up happening, guys, is we're going to have a winter that I think starts off maybe a little mild back and forth in December. It could snow. But January, and especially by February, I think is the core of the winter relative to averages. That's you're going to, I think we're definitely going to get one big snowstorm in February. And again, I could be wrong. I mean, some of the models that show the opposite of this pattern could be true due to this killer strong El Nino. But again, I think it would be premature to discount the warm water off the Baja and off the West Coast, because we know, because of the baroclinic boundary, that it could take that trough and, unlike 1998, pull it just enough to the west where we have a perfect ridge position and a perfect jet underneath for large northeast snowstorms. Again, here's a depiction of the jet stream using my analogs. That gives us a lot of snow, and when it's all said and done, we'll see if this verifies. Thanks for checking in, guys. Sit back and let's see how this unfolds.